All right, algebra students, welcome back. This is Mr. Von Ah. Our last video, I said that it was the last video for graphing quadratic functions. However, I decided to just go ahead and divide the last video into two parts. So, unless something changes, this should be the last video for how to graph quadratic functions. All right, and we are graphing them when they are in standard form, ax squared plus bx plus c. We talked about in the last video how we need to convert them to what I call vertex form so that we can pick out the line of symmetry in the vertex so that we know how to set up our graph. All right, so in this example, well, in our previous example, a was 1, right? So it was really easy. In this example, a is not 1. A is, in this case, 3. So it's a little more complicated when you have a greater than 1. So let's find out how to do that today when a is greater than 1. All right. So again, first thing we need to do is we need to complete the square. And the way we like to do this is first sanction off that part of the trinomial and then stick this guy on the outside. This is basically going to be forming our k value at the very end, right? Our constant. All right, so with this part of the trinomial, we're going to complete the square. All right, so in order to complete the square, we need, first thing I need to do is I need to factor out this 3. Okay, I can't have a 3 there to make a perfect square, trinomial. So what I'm going to do is I'm going to factor him out. Okay, so that's going to give me 3. I'm going to factor him out, and that's going to give me x squared right there, right? 3 times x squared is just 3x squared, plus, okay, so 3 times what gives me 12x? Well, 3 times 4 is 12. So 3 times 4 is 12, but I need that x right there, correct? So I factored out that 3, but I did not factor it out of this part, right? This 13 was not affected because he's outside the parentheses. Okay? So whenever you have a greater than 1, you need to factor him out. Okay? And that number right there is going to form that a on the outside of the parentheses. Okay, now we can complete the square here. So this is going to be 3 times x squared plus 4x. All right, now I need to know what my c value needs to be, right? What does that c value need to be for this to be a perfect square trinomial? Do you remember the formula? Well, it was just c equals b over 2 squared. Remember that? That's how we complete the square. So b in this case is 4. So 4 divided by 2 is 2. 2 to the second power is 4. All right? So c needs to be 4 for this to be a perfect square. So you know what? I'm going to write that in red because I'm adding it, right? So if I add 4, now here's kind of the tricky part, so follow me closely. So last time I said, okay, we added 4, so that means we just need to subtract 4 over here, right? So I remember I said, hey, if I give you $4 and then I take $4 away, the net result is 0. I didn't do anything, right? We can't just artificially add numbers to an equation unless we subtract the same number out. Right? So 4 minus 4 is 0. But here's the problem. I actually didn't add 4 to the left to this trinomial. Okay, now watch closely. This 4 is being multiplied by that 3, isn't it? So really, how much did I add? I didn't add just 4. I added 3 times 4. Because you see how this 4 is inside of these parentheses, correct? And everything inside of these parentheses is being multiplied by 3. That's why I changed this from a 12 to a 4, right? Because 3 times 4 was 12. So if I'm going to put a 4 there, I have to multiply that 4 times the 3. So I'm actually not adding 4. I'm adding 12. So I have to subtract 12 to that side, or to the constant. Now, hopefully you caught that. I mean, if you want to, you can write it like this instead of writing it as just negative 12, because later on when you look at your notes, you'd be like, well, how did I get that 12? Well, put a little comment over here. Now that's 3 times 4, right? And just so you know how you got that. And we subtracted it because we added it here, so we have to subtract it here to make it all come out even. All right, so that's really the trickiest part of this, is when you got that A on the outside, you got to be careful, because that guy right there is going to be multiplied by the A, okay? All right, so now I can go ahead and factor this trinomial, okay? And I know that that is going to end up with as 3 times, okay? Square root of 4 is 2, so I know that's going to be 2, and they're both positive. So it's going to be x plus 2 times x plus 2. All right, you can do the AC method on that if you want. Now I have to do the subtraction here. 13 minus 12 is 1, positive 1. Okay, starting to look a little bit more familiar, huh? Okay, now I have x plus 2 times x plus 2, which I can express that as x plus 2 to the second power, but don't forget about that 3. This is x plus 2 to the second power plus 1. All right, does that look familiar? That is in what I call vertex form. Okay, I'm sure it's called something else, but that's what I call it. All right, so now that I have it in vertex form, I can figure out my vertex and my line of symmetry right now, before I even graph it. Okay, I know that my horizontal shift is what? Well, my horizontal shift, this has to be a negative 2 to make this a 0. So my horizontal shift is a negative 2. So I know that my vertex is at x equals negative 2. There, let me do this right. My vertex is at x equals negative 2. All right? Right there. And I know that my, excuse me, that's wrong. My line of symmetry, my line of symmetry is at x equals negative 2. My vertex is an ordered pair. My vertex is going to be, well, the x coordinate is going to be negative 2. All right? And my y, or my f of x coordinate, is going to be 1, positive 1, right there. All right, so I know that my vertex is going to be, whoop, right there. So that means my parabola is going to look something like this. All right? Okay. Now, mind you, if that was a negative 3 out here, the parabola would be upside down. All right, just a reminder. Okay, so now let's go ahead and do something that we don't have any room for. Let's go ahead and make our table. I'm going to have to clear out some space here. Okay. So here's my x, and there's my, actually this is not f of x, this is g of x, isn't it? g of x. Sorry about that. All right, 1, 2, 3, 4, 5, 6, 7. We make 7 rows. Now my x, I know that my line of symmetry is at x equals -2. So right here, I'm going to put a -2. Now I'm going to choose 3 values less and 3 values greater. So 3 values less, -3, -4, -5. 3 values greater, -1, 0, and 1. All right. Now we have our x values. Now we just need to find our g of x values. All right, so at x equals -5. At x equals -5, so -5 plus 2 is -3. 3 squared is 9. 9 times 3 is 27. 27 plus 1, 28. So we're getting really big g of x values, right? And the reason is because of this a. Remember when I said that when a is great, the bigger the a gets, the more narrow it gets, which also means your g of x values are going to be up higher. Okay, we're not going to be able to graph that. It's going to be off of our coordinate grid system. How about when x equals -4? -4 plus 2 is -2. -2 squared is 4. 4 times 3 is 12. 12 plus 1 is 13. Boy, it's going to be hard to graph that one too. How about an x equals -3? -3 plus 2 is -1. -1 squared is 1. 1 times 3 is 3. 3 plus 1 is 4. So remember to do the correct order of operations, right? First you got to take the exponent, then the multiplication. First you got to do the grouping symbol, then the exponent, then the multiplication, then the addition, right? It's all there. Okay. How about when x equals -2? Well, I actually should already know that. At x equals -2, at x equals -2, y, or f of x should be 1. All right? Now here's the thing. When a is greater than 1, sometimes these values down here are going to be different than these values. Okay, let's check it out and see. Okay, at x equals -1. -1 plus 2 is 1. 1 squared is 1. 1 times 3 is 3. 3 plus 1 is 4. Hey, that one worked out. Okay, let's see if this one works. At x equals 0. 0 plus 2 is 2. 2 squared is 4. 4 times 3 is 12. 12 plus 1 is 13. That worked out. So my guess is that this one will work out too. And I don't really care because I'm not going to be able to graph that one anyways. All right, so there's my ordered pairs. Now I just need to plot them and sketch my graph. All right, so as I said, -28, I don't have enough room. Okay, -4, 13. Yeesh, I don't know if I'll have enough room on that one either. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, hey, how about if we just kind of fudge it? And we'll say that it's right there. All right? Close enough. And we got -3, 4. So 1, 2, 3, and +4. 1, 2, 3, 4. And then we got -2, 1, which is right there. We already have it. -1, 4. -1, 4. And 0, 13, which is going to be up here somewhere. All right, so see how skinny this thing is? It's skinny because of that 3 right there. So when we plot this, just remember when you make your parabola, this is not a point. Okay, it's actually rounded end. But this is a very narrow parabola. Again, because a was greater than 1. All right, so the main thing on this is you got to complete the square. Don't forget, when a is greater than 1, when you add a number right here, you got to multiply it by this this number that you factored out to get to that number. That's the biggest difference when a is greater than 1. All right. I hope this video was helpful. I really hope that you're growing and that you're learning. Remember, there's something called productive struggle. Don't be afraid of struggle. Try your best. Struggle through some of this stuff. You have lots of helps, lots of resources. As you struggle, you'll start to grow and you'll start to learn. All right? Well, make sure you subscribe to my channel so you get more videos as I make them. And until then, my friends, may God bless you abundantly.